my friends, and welcome to another one of Miss Claire's instructional videos. Today we're going to be talking about equivalent expressions and how to identify equivalent expressions. So, from the simulator, we were talking about how we had this really long list, and we could simplify it down to 8 bags of flour plus 11 bags of rice plus 2 bags of coffee. So, these two expressions are equivalent, meaning they give us the same information, they give us the same values, because we used this long expression to simplify down into this short expression. So let's talk about doing a quick gut check of if expressions are equivalent. One way that we can check if expressions are equivalent are by substituting in a value and the same value for each expression. And if they have the same output, meaning if they equal the same thing in the end, then at least at that value, they are equivalent. So let's start here. If I plug in a equal to 1, so I plug in 1 everywhere I see an a, it's going to give me a 1 right here. So we do this grouping first, and the highest level that I see is a level 2, so I do 3 times 1, that gives me 3. Then I finish up what's inside the grouping with 3 plus 6, that gives me a 9. Now that the grouping's all done, I'm going to do this last level 2, this multiplication. That's 3 times 9, and that is 27. Okay, so with our second equation, or our second expression, if these two expressions are equivalent, we'll get a 27 at the end. So let's see if that happens. When I plug in a 1 for my a in 9a plus 18, 9 times 1 is 9. 9 plus 18 is 27. Great, so these two expressions are equivalent at a equals 1. So for our last one, I'm going to let you plug in or substitute in 1 for a everywhere you see it, simplify it down, and then we'll come back and see if these expressions are all equivalent at a equals 1. So we're back and we can see that yes, indeed, all of these three expressions are equivalent at a equals 1. So let's talk about another way to show that two expressions are equivalent, and that's by simplifying them down to the same thing. So not necessarily substituting in a value, but simplifying the expression fully. So this, you can tell that the expressions are equivalent for all values of any variable. If I have 2 times the quantity n plus 3, what that means is I have n plus 3 2 times, right? So I have n plus 3 plus n plus 3. It's already looking suspiciously similar to our next expression, but we can simplify this further. I can combine my like terms like we did in the last lesson, and I have my n's that I can combine, so I have 2 n's. I have my 3's that I can combine, so that's 2 3's, or 2n plus 6. With this second expression, I can combine my like terms. So I have n plus n, that gives me 2 n's, and 3 plus 3, so that gives me 2 3's, or 2n plus 6. They simplify down to the same thing, so these expressions are equivalent. They equal the same thing. They give us the same information. So a simpler way of doing this is the distributive property, meaning I don't need to go through all these steps. If I have 2 times n plus 3, I can say I'm multiplying every term by 2 here. And it's only the terms. I'm only multiplying the terms by 2. So I can distribute that, and that means that I have 2 n's plus 2 3's. And again, I end up with the same situation, just a faster route. So with that, I want you to fill in this remaining vocabulary, and I will see you in the next instructional video.